All right, welcome back once again. Today we're going to continue from yesterday's lesson. Yesterday we compared fractions by building them with manipulatives and then by shading in our fractions and then seeing which had more shaded. That would be a good thing to mention. Whatever is shaded is what you have. We don't look at the part that is not shaded as what is there. We look at the part that is shaded. The parts that are empty, it's empty space, so it's not there. Now, moving on from that, today we are going to be comparing fractions by drawing the fractions. Now, I said last week, you can draw circles to make fractions, but first of all, difficult to draw perfect circles. Okay, that's okay, but it's kind of lopsided. And so then if I try to draw the same thing to compare it, okay, they're sort of the same, but not quite. So I'm not going to use circles. I'm going to recommend that you guys use rectangles because we already have straight lines on the papers that you guys have. So why not use them to our advantage? I'm going to start. Well, first, let's get a problem to compare. Let's say I have 1/8 versus 3/4. Let me write that down. 1/8 versus 3/4. We want to know whether 1/8 or 3/4 is greater. Well, before we even do that, what do you guys think? 1/8 is greater or 3/4 is greater? All right, well, let's try it. As I'm drawing these fractions, because this is going to be something you're going to want to be able to use on ACAP, a strategy you're going to want to be able to use. We want to make 100% sure that our fractions, our wholes, are the same. Because remember, if you go to a birthday party and there are 2 cakes there, if there is a cake the size of a tire on a car, and then there's another cake that's the size of, I don't know, a coffee cup, and you get 1/8 of the one that is the size of the coffee cup, and your friend gets a piece that's 1/8 of the size of the wheel. Is that fair? Okay, we've got our wheel, we've got our coffee cup. We can cut both of these into eighths. Imperfect, but it's all right. We get the idea. Okay, your friend gets this much. That's 1/8. And you get this much, that's also 1/8. Are you going to be happy if you get this? You're absolutely not going to be happy if you get that. So we want to make sure that when we're drawing fractions to compare them, that we are making sure that our wholes are pretty much the same. Let me plug in my computer. All right, good. Didn't want the computer to die while I'm making a video. So let's get back to it. So we want to make sure, first of all, that the whole is the same size. Otherwise, none of this matters. It's not fair. Even if we have all 8 of these 8s, it's basically going to be the same as 2 8s here. So can't do that. So now, back to our 1/8 compared to 3/4. Well, we want this one to be 1/8. We want this one to be 3/4. And notice also, I'm not drawing these like one on one side of the page and then drawing another way over here and just, hoping they're about the same size. And then once I draw in the fraction, I'm going to look at them way across. You can't tell you can't tell that. If you go to the beach and you look at somebody way down about a mile away, you can see them, but they look like an ant. Or if you've ever been on a roller coaster or in a plane or in just a really tall building and you look down at people, they look very tiny. But as you get closer to them, you might realize, hey, they're really tall. Or I've been to some football games or basketball games when I was in college, and from a distance, the players didn't look that tall. When I got up next to them, I had to look up to see them, and I'm 6 feet. So when you're really far away from something, or when the two things are not close to one another, you can't really compare it well. So make sure you're drawing right above one another in the same spot so that you can compare them most efficiently and accurately. Okay, here we go. 1/8. Well, if I'm doing 1/8, my denominator is telling me that my whole has to have 8 parts. So I'm going to start. It's an even number, I'm going to split it down the middle. Okay, pretty close. Now, since it's eighths, I want to think, well, how many eighths are going to be in each half? Okay, what's half of 8? Well, it's 4. So I'm going to have 4 in each of these halves. So I can just, honestly, I can half this again. How many parts do I have now? 1, 2, 3, 4. I need 4 more. So I'm going to half each of these one more time. Okay, there's eighths. And since I only have 1, I'm going to shade 1. And again, we don't want to just randomly pick one. I would suggest either starting on the left or the right. Might make more sense to start on the left. Okay, so now our fourths. Now this part is really important. These are eighths, these are fourths. We know that eighths and fourths can line up pretty well. So I can use my eighths to make my fourths. In fact, remember before I put these partitions in here, I actually had 4 parts. So if I can just find those parts again, let's see, here's 2 eighths, 2 eighths, 2 eighths, 2 eighths. You guys don't have to draw all this, but this is just kind of giving you an idea. So we have a fourth here, a fourth here, a fourth here, and a fourth here. So I'm going to find my middle point, and I'm going to draw a partition at each of these sections, and I have 4 parts. And see how they line up with these so we can conveniently compare them? Okay, if I were to just shade in 1, we would have 1/4. And remember from yesterday, 1/4 is going to be greater than 1/8, even though 8, the number 8, is more than 4. But because it takes fewer of these to fill the same space, they're larger. Because it takes more of these to fill the same space, they're smaller. We need 3/4, but we can already tell that 1/4 is going to be greater than 1/8. So if we get 3/4, definitely more than 1/8. So we can confidently say 3/4 is greater than 1/8, or 1/8 is less than 3/4. Okay, let's do one more example. Here we are. Sorry, I got a message. Let's do 2/3 versus 2/4. This one may be a little more complicated. I'm just going to get a new paper. 2/3 versus 2/4. So once again, first step, we want to draw our holes. We want to make sure the holes are the exact same size as one another, or at least extremely close. Close enough that you wouldn't be upset if you got one or the other at a birthday party. So we want this top one to be 2/3, bottom one to be 2/4, okay? Some people may look at this and say, oh, well, there's 2 of them. There's 2 on each side, so they're equal. They're equivalent. So they would put equal in here. But these denominators make a huge difference because remember the denominator tells us the size of the parts to make up the whole, as well as the number of parts to make up the whole. Up here, it just tells us how many of those parts we have. So we're going to have 2 here and 2 here, but they're going to be different sized parts. Let's start with the fourths, because that one's going to be a little bit easier. Remember, find the half. Here's a half. And I'm going to cut each of those in half with a partition, and I have 4 equal parts. Okay, I can go ahead and shade 2 of them. So we have 2/4. Now, 2/3. Remember, thirds are a little bit more difficult. But think about what we know. 1/3 versus 1/4. Which is greater? Well, I'm actually going to pull out some manipulatives because they're here. 1/3 versus 1/4. Anybody remember which is greater? It takes 3/3 to make a hole. It takes 4/4 to make a hole. So which one do we have to squeeze more in? We have to squeeze more fourths in. So that means they've got to be smaller. So 1/3 is greater than 1/4. So we could actually look at that and say, well, since I know 1/3 is greater than 1/4, then that must mean twice as much would be more than twice as much. But let's do it anyway. So with that in mind, as we're drawing this, we want to think 1/3 is greater than 1/4, but it's not as much as 2/4. So we want our third to kind of fall somewhere just a little bit beyond the fourth. Here's our fourth, here's the third. And then it's 2/3. 2/3 is going to be compared to 3/4. Let's actually look at it. 2/3 is going to be just less than 3/4. So then here's 3/4, We want our line to come just a little bit before that, and look at that. They're pretty even, pretty even. So now I'm going to shade them in. Which is more, 2/3 or 2/4? Well, we see both in our drawing and with our manipulatives that 2/3 is more than 2/4. And we see that right here. And so we're going to put our greater than symbol. 2/3 is greater than 2/4. 2/4 is less than 2/3. Today's assignment is going to look something like this. You're just going to be given different fractions to compare. And you are to either use logic, reasoning, such as the one we just did. We could have said, oh, well, I know 1/3 is greater than 1/4, therefore 2/3 must be greater than 2/4. You can use that, but for other ones, or if the denominator is the same, like here, 12ths versus 12ths, if I have 6 of something, it's going to be less than 11 of that same thing. If these are the same size parts that make it up, I have 6/12ths and 11/12ths. 11/12ths would be greater, right? So we can use reasoning like that. But when it comes to some other things, like 4/6 versus 2/4, okay, there's some other things we can think about that we'll think about tomorrow. But for today, it'd probably be best for you to draw a picture of it and then write the correct symbol in the box. Once again, good luck. I'll talk to you tomorrow.